Time feels like it moves. It feels like yesterday became today. It feels like the future is open and the past is fixed. However, I use the past several videos to explain that in a block universe, past, present, and future are all fixed in space time, with our lives mapped as coordinates on a world line. So, why is it that we seem to feel the flow of time? To answer that, we need to understand entropy because once we understand the physics of entropy, our feeling that time flows makes perfect sense. Hi, I'm Lisa. Welcome back to Biblical Reality Check. I will answer the question about the flow of time, but first I need to take some time to talk about entropy because that will be key in your understanding about why it feels like we are moving through time. First, let me clear up a couple things. We often hear that entropy is disorder, chaos, or messiness, but that's not the whole picture. A pure definition of entropy would be that it is the number of microscopic ways something can be arranged while still looking the same overall. This definition leads us to two key ideas: macro states, which are the big picture states you can see, and micro states, which are the tiny details you cannot see. Let's break it down. A macro state is the overall condition of something. Some examples are a tidy room, an ordered deck of cards, an ice cube that is solid, and coffee that is hot. A micro state would be the microscopic details of the macro state. For the examples just given, some corresponding micro states would be the position of every dust particle in the tidy room, the orientation of every card fiber, the vibration of every water molecule in the ice cube, and the speed and direction of every molecule in the coffee. Entropy is what connects the two states. A low entropy state is one in which few microstates correspond to the same macro state, while a high entropy state is one in which many microstates correspond to the same macro state. Wow, I know that probably didn't make a whole lot of sense. So let's use the example of a deck of cards to illustrate a high versus low entropy state. Let's say you have a perfectly ordered deck of cards, ace through king, four suits. There are very few ways to arrange the deck so it looks perfectly ordered. This is low entropy. However, if you shuffle the ordered deck, there are quadrillions upon quadrillions upon quadrillions of possible shuffled arrangements that could result. This is high entropy because when you shuffle, you will almost certainly end up with a random deck, not because the deck wants to be messy, but because messy states are overwhelmingly more common than ordered ones. Ludwig Boltzmann mathematically proved that the macro state with the most microstates is the one the universe will almost always be in. Why? Because if there are a trillion, quadrillion microstates that look messy and only a handful that look ordered, then you will almost always find the system in a messy state, not because disorder is natural, but because disorder is more common. You don't need to know the math he used. You just need to know that entropy increases because high entropy states outnumber low entropy states by cosmic margins. This is called statistical inevitability, and it is exactly why time feels like it flows. Let me explain. Up to this point in the series, we've explored the possibility that time does not flow at all. In the block universe model, every event in your life already occupies a location in space-time, much like every city already occupies a location on a map. But if that's true, A question immediately arises. Why doesn't life feel that way? Why does the future seem unwritten? Why does the past seem fixed? Why do we feel ourselves moving from one moment to the next? Entropy turns out to be the missing piece of that puzzle. The first thing to understand is that the laws of physics work the same way forward as they do backward. However, entropy does not. Entropy almost never decreases. It's not because it can't, but because, as we already pointed out, the statistical probability of it doing so is so minute. This creates the arrow of time. The arrow of time is not a force. It's not something pushing the universe forward. It's simply the observation that systems almost always move from less probable states to more probable ones. From the perspective of everyday life, that statistical tendency becomes so reliable that it feels like a fundamental feature of reality itself that presents as the flow of time. Remember that ordered deck of cards we talked about? Imagine filming yourself shuffling the deck. If you play the video backward, you would see cards leaping into perfect order, randomness collapsing into structure, and chaos becoming symmetry. You would instantly know the video was reversed. Why? Because entropy almost never decreases. This is the arrow of time. Time feels like it flows forward because entropy overwhelmingly increases. Our brains are part of that process. Memory, perception, and cause and effect all depend on entropy increasing. Memory only works in one direction because when your brain forms a memory, neurons fire, chemicals move, heat is released, and microscopic disorder increases. You have memories of the past because entropy was lower then. You can't remember the future because your brain hasn't yet encountered that slice of space time. Yesterday had lower entropy than today. Your brain, your body, your room, your environment all moved from fewer possible arrangements to more possible arrangements. Yesterday, your phone had a certain battery charge. Your room had a certain arrangement. Your body had a certain amount of stored energy. Your coffee was hot, and certain memories had not yet been formed. Today, all of those systems have changed in ways that are overwhelmingly unlikely to reverse. That irreversible change is what your mind interprets as time passing. Your brain cannot go back to yesterday's exact configuration. This creates the illusion that yesterday is fixed, today is happening, and tomorrow is open. Entropy makes the future feel open because you haven't yet reached that part of space time. Your brain hasn't formed memories of it, and entropy hasn't increased in that direction yet. But in the block universe, the future is already written. Entropy is the physics behind the psychological illusion of openness. Entropy doesn't prove the block universe, and it doesn't tell us everything about the nature of reality. What it does tell us is why time feels the way it does. It explains why we remember yesterday but not tomorrow, why the past feels fixed and the future feels open, and why consciousness experiences reality as a sequence rather than a completed whole. If the block universe is correct, entropy may be the reason we experience ourselves moving through a world that, from a deeper perspective, is already there. But this raises an even bigger question. Physics can describe entropy, space time, and the mathematical structure of the universe. But can physics explain consciousness itself? Can it explain meaning, purpose, experience, or the feeling of being aware? As we move forward in this series, we're going to draw an important distinction between what physics can tell us and what it cannot, because understanding the limits of science may be just as important as understanding its discoveries. And that's where we're headed next. See you there. Thanks for watching.